Planck black hole. First up, the Planck black hole. This is a completely theoretical idea involving the smallest scales we can imagine in physics. We're talking about something unbelievably tiny, far smaller than an atom. But here's the catch. Nobody has ever observed one. Planck black holes are theoretical objects that appear when physicists explore where quantum mechanics and gravity collide. So this tiny black hole is an idea, not a discovery. Next are primordial black holes. Unlike ordinary black holes, these wouldn't need a star to create them. They may have formed directly from extremely dense regions of the early universe. The crazy part? We haven't confirmed that primordial black holes exist. If they do, they could tell us about the universe's earliest moment. May even be related to some ideas about dark matter. 3. Kugelblitz. A Kugelblitz is one of the strangest ideas on this list. Instead of forming from matter, it's a theoretical black hole created by concentrating an enormous amount of energy into a tiny region. Why does that work? Because energy contributes to gravity. So, in principle, if you squeeze enough energy into a small enough space, gravity could become strong enough to create a black hole. 4. Micro black hole. Micro black holes are hypothetical black holes that could be incredibly tiny. Some theoretical models have even explored whether particle collisions could produce microscopic black holes, but we've never confirmed one. And according to Hawking's theory, tiny black holes should lose energy through Hawking radiation, eventually disappearing. So they could be incredibly short-lived.
Stellar mass black hole. Stellar mass black holes are the classic black holes most people imagine. They can form when massive stars run out of fuel and their cores collapse under gravity. The result can be a black hole several times more massive than our Sun, packed into an incredibly small region. And if it has a companion star, it can pull gas away from it, creating a superhot accretion disk. We often detect the black hole by watching the glowing material around it. 6. X-ray binary. An X-ray binary isn't actually a separate type of black hole. It's a system where a black hole has a companion star. The black hole's powerful gravity pulls gas away from that star, and the gas spirals inward into a superhot accretion disk. As this material gets hotter and hotter, it releases enormous amounts of X-ray radiation. And that's how astronomers can find something they can't see directly. The black hole itself is invisible, but its dinner is glowing. 7. Rogue black hole. Now imagine a black hole with no star orbiting around it, and no obvious home at the center of a galaxy. That's where rogue black holes come in. These black holes could travel through space after being kicked out of their original systems by violent gravitational interactions. The strange part is that they could be almost completely invisible. We might only notice one if its gravity bends the light from a distant star. So somewhere in the galaxy, invisible black holes could be wandering through space. 8. Binary black hole. What happens when two black holes meet? They can become a binary system orbiting around a common center of gravity. As they spiral closer together, they lose energy by sending gravitational waves through space. Their orbit gets faster and smaller until the two black holes finally merge into one. That collision can release an enormous burst of energy as gravitational waves. And in 2015, LIGO detected gravitational waves from a black hole merger for the first time. We weren't just seeing the universe anymore. We were listening to Spacetime. 9. Intermediate mass black hole. Between stellar mass black holes and the supermassive monsters at the centers of galaxies, there may be a mysterious middle ground. These are called intermediate mass black holes. They could contain hundreds, thousands, or potentially much more mass than our Sun. The problem is that they're incredibly difficult to confirm. Finding more of them could help explain how small black holes eventually became the enormous black holes we see today. In other words, they could be the missing link in the black hole family. 10. Supermassive black hole. Now we're talking about the monsters. Supermassive black holes can contain millions or even billions of times the mass of our Sun. They're found at the centers of many large galaxies, including our own Milky Way. At its center sits Sagittarius A star, with a mass of roughly 4 million suns. But some galaxies contain black holes billions of times more massive. And one of astronomy's biggest mysteries is how these monsters became so massive so early in the history of the universe. 11. Quasar. A quasar isn't technically a type of black hole. It's what happens when a supermassive black hole is feeding extremely aggressively. Gas and dust spiral around the black hole, forming a superhot accretion disk. That disk can release an incredible amount of energy, making the entire system shine brighter than its surrounding galaxy. Some quasars are so bright that we can see them from billions of light years away. So when you see a quasar, you're basically seeing a supermassive black hole having one of the most energetic meals in the universe. 12. Blazar. A blazar is basically a supermassive black hole with one of its powerful jets pointed almost directly toward Earth. These black holes can launch enormous streams of particles from the regions around them at speeds extremely close to the speed of light. When one of those jets points toward us, its radiation can appear incredibly bright because of relativistic effects. So a blazar is like a cosmic flashlight aimed directly at Earth, and we're standing billions of light years away, watching it shine. 13. Ultramassive black hole. If supermassive sounds huge, ultramassive takes it to another level. Some of the most massive black holes known may contain tens of billions of times the mass of our Sun. They're found in some of the largest galaxies in the universe and can influence enormous regions around them. But here's the mystery. Scientists still don't fully understand how black holes can grow to such extreme sizes. At this scale, calling something simply massive almost doesn't seem appropriate anymore. These are some of the biggest gravitational monsters we know. 14. SLAB black hole. Now we're entering much more theoretical territory, the Slab black hole. Unlike the familiar spherical black holes we normally imagine, slab-like hole concepts come from unusual theoretical setups involving different geometries and gravitational conditions. These aren't objects astronomers routinely observe in space. Instead, they're useful for physicists exploring what black hole horizons and gravity might look like under unusual conditions. So think of this less as a confirmed cosmic object and more as a strange thought experiment from theoretical physics. 15. Naked singularity. And finally, one of the strangest ideas on the list, the naked singularity. A normal black hole has an event horizon hiding its central singularity, from the outside universe. But a naked singularity, as the name suggests, would have no event horizon covering it. That would completely change what we expect from a black hole, because the extreme gravitational region could potentially be visible from outside. But there's a huge catch. We've never observed one, and we don't know if nature can actually create one. For now, it's one of the universe's biggest theoretical mysteries, and that's just the beginning. From microscopic black holes that may disappear in an instant to monsters containing billions of suns, black holes are some of the strangest objects in the universe. But there are still countless cosmic mysteries left to explore. So if you want to understand the universe one strange idea at a time, subscribe, and I'll see you in the next one.